Okay, now let us do a bit of revision of logistic regression. So the data set that I found is death or survival from stings of a giant Asian hornet. Sorry, I forgot where I took it. It was some medical journal, so I just manually extracted these 16 records. It is a very small data set, so here n is just 16. So we are going to predict the death of survival, and death is going to be 1, and survival is going to be 0. So first, we're going to use the number of stings as the only predictor. Recall some terminology. So this is sigmoid function, is e to the z divided by 1 plus e to the z. And recall that in order to compute the logistic regression, what we do is we first take the matrix product of our input vector x while transposed and the vector of coefficients beta. Well, either we can write it as x transposed beta, or we can also write it as beta transposed x. In any case, we apply the sigmoid function to the output. So in either case, we take the product of the two matrices, or it is the same as the dot product of the two vectors. The result is a scalar, and then we apply our sigmoid function to this scalar. Right. So the output of this, the final number, is the estimated probability of death given the input, given the observed number of stings. So then the value of beta is the one that minimizes the cross entropy loss function, right? So this is the cross entropy loss function. This p, you can also denote it as yi hat. Yi hat is the probability, estimated probability of death from hornet stings, right? So, and this cross entropy loss function, it comes from maximizing a likelihood of observing the given beta given the vector x. In any case, so it means that hypothetically, if you give me some value of beta, then I could plot my logistic regression on the y-x-axis. So the number of stings here is my x, is the only predictor. Right, so the value of y should be between 0 and 1 because it is probability. And for every value of beta, I can hypothetically calculate the loss function, right? So for example, if my beta were equal to -5,4, then the loss would be equal to 63. I could figure out how many observations are misclassified, and this is 1, 2, 3, 4, 5, 6, 7 observations here are misclassified, and they are kind of misclassified by a really large margin, right? So the distance, so for them, my hypothetical logistic regression predicts that the probability of death is almost 1, but it is in fact, so the people actually didn't die, right? So it should be probably closer to 0. Right, and the estimated probability to die from 50 strings here is, well, almost 1. Now, let's try a different, again, hypothetical value of beta, right? So here we see that the fit is much better. So at least there are just 3 observations that are misclassified. There is one that is not very clear whether it is misclassified or not, because for it is 50 and the probability to die is precisely 1/2, right? So it depends on whether we want to classify death if the probability is strictly bigger than 1/2 or bigger than or equal than 1/2, right? Well, in any case, so let us say maybe we classified it correctly, but still that there is kind of a large distance, but still. In the previous picture, there were 4 of them that are 7 were misclassified. Now there are just 3 or 4, and the distance is kind of smaller. So which is how we see that this model is better, and the loss function is definitely much smaller, right? So instead of 63, we got 12 point something. Now the value of beta that minimizes the loss function, the optimal one, right? So this is the one that I fitted in R. is this one that you see now. So notice that, strictly speaking, 3 observations are still misclassified, right? So this, and this are misclassified. So now this observation is classified correctly because the probability here is slightly more than 0.5, right? So this is classified correctly. Well, at the same time, so we see that in a lot of these observations, there is kind of a noticeable gap between the actual training data point and the blue graph of prediction. But apparently it's not, it doesn't really penalize our model too much, right? So what we see here is that only if, so our model is penalized for misclassification only if the distance is really large, right? So only if it is extreme. But if it is like, I don't know, 0.25, 0.3, then it's probably not so bad. Right? So which means that usually logistic regression, so the fitted model is not too extreme, right? So it doesn't really want to make predictions that are too confident. That this is what we see on the picture. So here is the graph of the function. So the point of this is just to see that we can just think of it as a function of 2 variables that we can just plot, and its graph is a surface in the 3D space. So at the same time, what we see is that really, the graph of this function is kind of is very long probably, and kind of a bit narrow. So it is like a hole, but it's very long hole and very narrow hole, right? And it's not really very clear where exactly the minimum value is. Right, so here is a little quiz for you.